Imagine a financial analyst with perfect discipline, one who never sleeps, never takes a break, and grinds through market data while you're still brewing your morning coffee. By the end of this video, you will have built exactly that. This system is an autonomous AI agent designed to research markets, execute paper trades, and report back to you daily, entirely on its own. To pull this off, we need a model capable of deep reasoning. Anthropic's Claude Opus 4.7 includes a setting called adaptive thinking. This mode allows the model to dynamically pace its logic, making it exceptionally effective for the multi-step technical work required for trading. You need 5 tools to get started: the Claude desktop app on a Pro or Max plan, a free Alpaca account for paper trading, an API key from Perplexity for research, ClickUp for notifications, and a standard GitHub account. This process moves beyond manual, one-off prompting toward the deployment of a fully autonomous, headless execution environment. Traditional automations like Zapier run on rigid, preset tracks. If a single step breaks, the whole chain fails. Claude recently introduced routines, which allow the AI to self-repair. If an app goes down or a spreadsheet column shifts, Claude discovers a workaround on the fly. Even better, these routines run remotely. Claude spins up its own environment in the cloud, meaning your laptop can be completely shut down and stowed in your bag, and the agent will keep working. Let's test this with a simple warm-up. This is the Claude Desktop Routines panel. We will set a trigger schedule for 8 a.m. and connect 2 basic tools, Gmail and Slack. The instruction here is written in plain English. Check my inbox, summarize the last 3 emails, and post those summaries directly to my team's Slack channel. Verifying the agent can independently read your inbox and execute a communication task builds the technical foundation we need before handing over any market data. Now, let's look at the actual trading strategy. Opus 4.7 is highly capable, but it isn't designed for the high-frequency churn of day trading. We will task it with building long-term fundamental theses based on real company data. This chart shows how top AI models score on agentic financial analysis. Opus 4.7 reaches 64.4%, a benchmark that specifically rewards models capable of digesting complex financial filings and writing coherent investment theses. To put that analysis to work without risking real capital, you need to open an Alpaca paper trading account. This gives you a simulated environment with real market data to practice the system safely. Next, we link our tools securely. Rather than hard-coding API keys directly into your prompt, you will input your Perplexity and Alpaca credentials directly into the Claude Environment Variables panel. With the keys secure, we give the agent strict rules. We cap its maximum portfolio allocation to 5% per position, and we instruct it to automatically cut any losing trade at -7%. An AI that reasons through complex data is powerful, but it requires explicit, programmatic limits to manage risk reliably. There is a major technical hurdle here. Every time a cloud routine wakes up to run, it is completely stateless. It has no memory of the trades it made yesterday or the research it did an hour ago. We build a persistent memory structure using 3 specific markdown files. These act as the agent's long-term memory. We use a rigid loop. First, read the files. Second, act on new market data. Third, write new actions back into the memory. Because the model will process all of this data recursively, we need to control the context window. Opus 4.7 introduces a task budget, which gives Claude a target estimate for how many tokens to use during an entire agentic loop. By setting this budget, you ensure the agent prioritizes its workload and finishes gracefully. This prevents it from getting stuck in endless polling loops and draining your API funds. Giving the system a way to remember its past actions, paired with strict limits on how much it can compute at one time, transforms a basic script into an evolving financial brain. Now we set the agent's working hours. To minimize token waste, we align our cron jobs, the automated time triggers, specifically with actual market hours. We break the day into 4 intervals: pre-open for morning research, market open for executing planned trades, midday for tightening stops, and market close for logging results. Since our memory files are hosted remotely, we need Claude to have permission to update them. In the Claude Permissions panel, enable unrestricted branch pushes so the agent can sync data back to your repository. This allows the agent to finish its daily schedule by committing the updated trade log directly to GitHub. The next time the agent wakes up, it will pull down the latest version of this file. For the final step, we provide the agent with a ClickUp API key and instruct it to ping you every day at 4 p.m. with a clean summary of the portfolio's performance. By linking scheduled remote jobs to a version control system, the agent runs continuously on its own, completely independent of your local machine. With the architecture in place, we trigger a test run. The agent wakes up, reads its memory, pulls market data, and executes across the cloud. We can immediately verify the results. The Claude log shows the agent using Perplexity for targeted research. Simultaneously, the simulated trade appears in Alpaca, and the daily summary notification pings your phone via ClickUp. Now, let it run. Your job is to monitor its paper trading logic for several weeks, auditing its decisions, and tweaking its prompt guardrails to correct any mistakes. Do not connect a real brokerage account with real capital until the agent's trading discipline and risk management are mathematically proven in the paper environment. The combination of 4.7's reasoning, remote execution, and persistent memory results in a tireless digital analyst that researches, trades, and improves itself every day.